So the problem we have is one a couple of you asked about that we gave on homework, and it's interesting because if you know the empirical rule, you do not need the information, all the information that's given. So it says that dimes are normally distributed with a mean mass of 2.268 grams and with a standard deviation of 0.03 grams. And we have a vending machine that rejects all coins with weights more than one standard deviation above or below the mean. Okay? So it rejects coins that are outside of one standard deviation from the mean. Now, since this is normally distributed, well, we should read what it asks. Duh. That's rule number 1, I guess, or 0. What percentage of legal dimes will be rejected by the machine? Round to 2 decimal places, meaning it just wants a simple percentage. Because like 68% is 0.68, so that's 2 decimals. So let's think about this. What proportion of dimes then lie within one standard deviation of the mean? Well, if it's normally distributed, the empirical rule says 68%. So how much lies outside of one standard deviation from the mean? Above 1 or below 1 standard deviation from the mean? 32%. 100% minus 68% is 32%. But let's just use this. So there's your answer, 32%. But let's use this as a chance just to review one more time how to use the normal calculator on StatCrunch. So let's go over there real quick. So you can stop now if you know how to do that. So we are going to go to Stats, Calculator, Normal. Boom, there's our normal. Okay. Now we have a mean. Well, one we're going to do between. And you just have to remember when you do between, if you need something outside, sometimes you have to treat it like an SAT problem, that if you can find one area and you know the total area, you can do some kind of addition or subtraction, probably subtraction, and then a division by 2 because you know it's symmetric, and compute some other area. It's a stats, it's a, not stats problem, it's a SAT problem. So here we've got mean of, let me go back here. I guess we could compute a z-score, but we're not, 2.268. 2.268. So we got a mean of 2.268 and a standard deviation of 0.03. And what do we want? Well, we want the probability from that a random variable x is between 1 standard deviation below the mean up to 1 standard deviation above the mean. And you can actually type that in, that expression in. So I'm going to type in 2.268 minus 0.03, or you can do it on a calculator or a piece of paper. I can do that in my head, but I'm not. Well, it's 2.265, right? And over here, we type in 2.268 plus 0.03. So that's asking, what if I get a random value that's between 1 standard deviation below and 1 standard deviation above the mean? Okay, so let's compute that. And there it is. So this, as you will notice, is exactly 68.268949 Now we round that to 68%. And we could round it, be a little more accurate, 68.3%, but they said 2 decimal places. So between those two, it accepts dimes from here to here. And so the dimes it's not accepting is the ones in here and here. So the outside is 32%. And by symmetry, then there's 16% of them below that and 16% above that. So that's how to do that. And it just points out that it would be useful to know the empirical rule. It's useful to have some paper and a pencil. Useful maybe to have a little calculator. Or you can use this applet in here. Okay? See you soon.